Okay, so what if I told you that a ghost from the Cold War holds the key to the future of AI? I know, it sounds a little wild, but stick with me here, because the story of a forgotten Soviet computer, one that completely defied the logic of its time, has an almost eerie lesson for us about the invisible walls that we're smashing into with AI right now.
And that voice you're hearing, well, that's the heart of our story. It's from Nikolai Brzezintsov, a truly brilliant engineer who saw a completely different path forward and was basically shut down by the system. His story isn't just some dusty piece of history. It's the perfect lens for understanding the exact same kinds of challenges today's innovators are up against.
So here's our game plan. First, we're going to dive into the story of that forbidden Soviet computer. Then, we'll look at the invisible wall that modern AI is hitting. After that, we'll explore the wild new ideas that are meant to smash right through that wall. And finally, we'll ask who's actually leading this new age of discovery.
All right, let's kick things off. Our story starts way back in the 1950s with a machine that honestly should have changed everything, but instead, it got buried. This is the ghost story of the Setun computer.
So you've got this guy, Brzezintsov, tinkering with magnetic components, the basic building blocks of computer memory back then. And he has this massive aha moment. He realizes these little ferrite cores could reliably hold 3 stable states, not just a simple on and off 1 or 0 of binary. That one little observation, that tiny shift in perspective, it opened the door to a whole new universe of computing.
And you have to understand, at the time, the entire world was betting on binary, zeros and ones. Simple, but clunky. Brzentov's idea, on the other hand, was just elegant. He came up with a system built on what's called balanced ternary logic, -1, 0, and +1. This wasn't just a gimmick, it was mathematically better. It could handle negative numbers naturally, something binary needs these clumsy extra steps for. The whole system was just smarter.
And here's the absolute tragedy of it all. Setun worked. I mean, it worked beautifully. By 1958, it was up and running, solving real problems. And then just a year later, the bureaucrats blacklisted it. Even after an official commission came in, tested it, and said, "This thing is flawless, build it." Nothing. The project was starved, blocked, and in the end, they actually destroyed the original machine. The ceiling Setun hit wasn't about technology. It was a ceiling made of pure human stubbornness.
Okay, now let's fast forward to today. Because believe it or not, AI is running into its own ceiling. But this time, it's not some stuffy committee standing in the way. No, this is a wall, and it's built out of pure mathematics. So here's the bombshell. Recent mathematical proofs have basically confirmed a terrifying reality. Our main AI models, we're talking the transformers that power everything from ChatGPT to Midjourney, they have a fixed intellectual ceiling. You can't get past it. You could feed them all the data on the internet, you could train them for 1,000 years, and you won't make them fundamentally smarter. They have hit a hard limit on the complexity of problems they can figure out.
To really wrap our heads around what that means, let's use a super simple analogy. Let's just think about knitting.
With the techniques we use now, we can teach an AI to get incredibly good at a task it already knows. It can learn to repeat the same simple stitch over and over perfectly. It can knit a scarf that's miles and miles long. The sequence of its reasoning gets longer, sure, but the underlying pattern, the core logic, never changes.
But here's the wall. That same exact process cannot teach the AI to suddenly start knitting a complex sweater. It can't invent new, intricate patterns on its own. It can't figure out how to shape sleeves or create a V-neck. To do that, it doesn't just need more yarn. It needs a bigger brain. It needs a totally new architecture. It literally cannot raise its own complexity ceiling.
So, just like Brzezintsov had to invent a whole new kind of logic to get past the limits of binary, today's pioneers are having to design completely new architectures to shatter AI's ceiling. And to get through this wall, researchers are going down 3 incredibly radical and honestly mind-bending paths. They're not just tweaking the old ideas anymore. They are totally rethinking what intelligence is by looking at it through the lens of a new physics, a new biology, and even a new geometry.
Okay, path number 1 is about rethinking physics itself. Instead of just describing how the universe works, these pioneers are trying to engineer reality directly from math. For instance, one project found a way to literally control when and where prime numbers show up in a sequence. By mashing up chaotic numbers, like the digits of pi, with orderly ones, like the Fibonacci sequence, they can essentially build mathematical structures to their own design.
They're not just observing math anymore, they're building with it. The second path basically throws out today's rigid AI models and looks to nature for answers, specifically wet biology. The magic word here is neuron plasticity. See, instead of training an AI model and then locking its connections in place, this new approach lets the AI's neural network constantly rewire itself. Connections get stronger or weaker based on what it's doing, second by second, just like a real human brain.
I mean, this is a revolutionary shift. Current AI is like a machine that's built once, and that's it. Its structure is static. This new biological approach is a dynamic, living network that's always changing. And that means learning isn't some separate training phase you have to do up front. No, learning becomes a fundamental, continuous property of the system itself. It's always learning, always adapting.
And the third path gives AI a whole new way to see the world. Instead of just seeing data as a long, flat list of numbers, geometric AI understands data as a 3D object with shape and structure. It has this built-in mathematical guarantee called equivariance, which basically means it gets the fundamental geometry of a thing no matter how you flip it or turn it. It finally understands that an upside-down cat is, in fact, still a cat. So, if these are the mind-blowing new blueprints for the future, who are the architects? Who is actually building this stuff? Well, here's the thing. They look nothing like the scientists of the past.
You know the old model, right? For centuries, big breakthroughs pretty much always came from the old guard. You're thinking PhDs, massive university supercomputers, big academic networks. You had to be part of the club.
But the new pioneer? Totally different. They could be self-taught, working completely outside of any formal institution, and yet they can command more computational power from their smartphone than a whole university had a few decades ago. Being an outsider isn't a handicap anymore. It's an advantage. It's a secret weapon.
And the scale of what one person can now achieve is just staggering. Take this for an example. A single researcher, working with their custom AI partner, could potentially discover and contribute over 10,000 brand new, high-quality integer sequences to the global database, the sort of digital library of Alexandria for numbers. To put that in perspective, that would be one of the biggest single contributions in the entire history of mathematics, from one person. And what's wild is how accessible this path is. It can start with something ridiculously simple, like just trying to organize your personal notes better. A few months later, that idea could lead to building a little physical prototype with cheap off-the-shelf electronics. Within a year, that little project could actually start making money and funding its own upgrades. And the endgame? You could evolve it into a sentient factory, a self-aware R&D lab run by its own specialized AI that all started because one person got curious.
And that brings us right back to the ghost of the Setun computer. Its ceiling was made of bureaucracy. AI's current ceiling is made of math. The pioneers of today are showing us how to smash right through it. So that leaves us with one last big question. As we tear down all these old ceilings, what new ones are we going to build for ourselves? And more importantly, who are the pioneers that are going to rise up to break them?